In 1 second, it can circle the Earth more than 7 times. In 1 minute, it travels nearly 18 million kilometers. In 1 year, almost 9.46 trillion kilometers. That distance is called a light year. And it is the only unit that makes sense when we talk about the deep universe. When astronomers built the James Webb Space Telescope, they were not trying to see farther places. They were trying to see earlier time. Because in space, distance and time are the same thing. The farther you look, the further back you go. James Webb was designed to detect extremely faint light, not bright stars, not nearby galaxies, but ancient light, light that began traveling before the universe looked anything like it does today. In its earliest observations, James Webb began detecting light that should not have been there. Not because it was impossible, but because it came from a time when galaxies were not supposed to exist yet. To understand why this matters, we need to go back, far back. The universe is about 13.8 billion years old. After the Big Bang, there was no visible light for a long time. The universe was hot, dense, and opaque. Photons could not travel freely. This period is known as the cosmic dark ages. No stars, no galaxies, no visible structures. Just expanding space filled with simple particles, slowly cooling as time passed. Then, hundreds of millions of years later, the first stars began to form. Their light slowly started to escape. These early stars gathered matter around them, pulling gas together through gravity, creating the first rough structures that would later become galaxies. According to previous models, this process was expected to be slow, gradual, careful, limited. A universe learning to organize itself step by step. Older telescopes could not see this far back. Their sensitivity was not enough. They saw galaxies only after the universe had already matured, after structure had stabilized, after chaos had settled. James Webb changed that. With its powerful infrared instruments, James Webb can detect light that has been stretched by the expansion of the universe. Light that began as visible or ultraviolet has been pulled into longer wavelengths as space itself expanded. That light now exists in infrared. That is where James Webb excels. And then it happened. James Webb detected faint signals coming from extremely distant regions of space, regions so far away that their light began traveling less than 400 million years after the Big Bang. This was surprising, because according to earlier expectations, galaxies at that time should have been small, dim, and rare. Instead, James Webb observed structures that appeared larger, brighter, and more organized than predicted. This does not mean the science was wrong, but it does mean our timeline was incomplete. Some of these early objects appear to be forming stars at an intense and rapid pace. Others show signs of structure that suggest matter organized itself much faster than expected. James Webb did not detect alien signals. It did not find anything supernatural. What it found was something far more important. The early universe was more active than we expected. This light is not just old. It is ancient beyond intuition. When this light began its journey, Earth did not exist. The Sun did not exist. Even the Milky Way had not yet formed. Yet that light traveled. For more than 13 billion years, across expanding space, across changing structure, across a universe in motion, ignoring everything in its path, until it reached a telescope built by a species that did not exist when the journey began. This changes how we think about observation. James Webb is not looking at objects. It is looking at events, moments frozen in time. And here's the critical detail. Because space has expanded, those objects are now much farther away than 13 billion light years. Their current distance is closer to 40 billion light years. James Webb is not seeing where they are. It is seeing where they were, and where they are now may be completely unreachable. This means something profound. Some of the light James Webb detects comes from regions of the universe we can never visit. No spacecraft, no probe, no future technology. Even traveling at the speed of light would not be enough, because space itself is expanding faster than light can cross it. James Webb's discoveries do not break physics. They refine it. They remind us that early cosmic history was faster, denser, and more complex than our simplified models suggested. Scientists are careful. They do not claim final answers. They speak in probabilities, uncertainties, and revised timelines. But one thing is already clear. The first galaxies formed earlier and evolved faster than we once believed. This also explains why James Webb's images feel unsettling. They are not just beautiful, they are ancient. They show a universe in its infancy. Chaotic, bright, rapidly changing. Every deep image from James Webb is a glimpse into a time when the rules were still settling, when structure was emerging from darkness. This is why the phrase "light from before galaxies existed" is not poetic exaggeration. It is a literal description. James Webb is detecting light from an era when galaxies were only beginning to assemble, when the universe was still learning how to organize itself. And this light tells us something important. The universe did not wait quietly. It moved quickly. It built structure as soon as it could. When we look at James Webb's data, we are not just learning about the past. We are learning how everything that exists today came to be. The stars in our sky, the galaxies around us, even the atoms in our bodies are connected to processes that began in those earliest moments. James Webb does not show us answers. It shows us origins, and every new detection pushes the boundary of what we thought was possible in the young universe. We are not seeing the beginning, but we are seeing closer to it than ever before. That is why this matters. Not because it is mysterious, but because it is real, measured, observed, verified. James Webb detected light from a time before galaxies existed as we know them. And that light has been traveling longer than Earth has existed. The universe has been speaking for billions of years. We only recently learned how to listen, but there is another layer to this discovery that often goes unnoticed. James Webb is not only detecting ancient light, it is detecting patterns. Light carries more than brightness. It carries temperature. It carries chemical fingerprints. It carries motion. From faint variations in that light, scientists can estimate how fast early stars formed, how massive those structures were, and how violently energy was released. In the early universe, conditions were extreme. Gas clouds were denser, radiation was stronger, gravity acted faster because everything was packed closer together. This allowed stars to form quickly and burn intensely. Many of these first stars were likely much larger than most stars today. They lived short, violent lives. They produced heavy elements and reshaped their surroundings in a matter of millions of years. Those early stars did not simply shine, they transformed space. James Webb is seeing the aftermath of those transformations, regions where matter was enriched, heated, and pushed into motion. This helps explain why some early structures appear unexpectedly bright. Brightness does not always mean age. Sometimes it means intensity. The universe did not grow quietly. It went through a phase of rapid experimentation. Structures formed, collapsed, reformed, over and over again. Another critical insight comes from redshift. Redshift is not just a measure of distance, it is a measure of cosmic stretching. The higher the redshift, the more the universe expanded, while the light was traveling.